This is NITech load cell trainer, where we are providing one load cell unit with loading arrangement. So in this, one Western bridge circuit is there. After that, we have provided some low pass filter and some gain multiplication, some display arrangement and logical system. So to measure the different voltage, we require 2 voltmeter in this. This is the total setup. Now we will start the experiment with this. So first you should ensure that everything is off, and first this power cable you should connect there. Then keep this switch off. First connect this connector which is coming from the load cell unit. Then output of Western bridge, that is given to this terminal, red to red and plus to plus and minus to minus. So here you always ensure that plus should be connected with the plus. Here plus is there, and minus should be connected with the minus terminal, black to black and red to red. So now we can see that whenever any load is given on this, at the time here millivolt value will be shown in this meter. So this meter should be in millivolt range, and this gain circuit will give some amplification gain, and you can see the magnitude in the volt. This magnitude will be sensed by some microcontroller unit given inside this kit, and it will display the voltage measured value as well as with some gain and offset arrangement. It will show the load kept on this. So let us start the kit after the connection. So when you turn on the switch, you can see load cell measurement trainer. So here V in will be shown, that will be the this value, and here load value you can see here. So now we'll put some load on this. Let us put 1 kg load on this. This is the 1 kg load we kept. Now here on this meter you can see very small 0.9 millivolt value is observed here. That was 0 in before. So let us remove that and let us see that value. So if you remove this, you can see this value is reduced. So by default some 0.4 volt offset is there. Now we will add 1 kg. So here again the same value you can observe. So this shows the linearity. Now we are providing some gain here, and here that value is amplified to 0.3 volt. So same 0.3 volt is measured inside the controller, and you can see here that value is observed here. So in this kit 3 experiment can be conducted. So in first experiment, this LCD part you don't need to utilize. So in first experiment, 4 different loading arrangement given. You can put the different load here, and you can observe the reading of this meter, that is the input to this amplification circuit and output to this Western bridge. And then with respect to these values and load kept on this, you can take the reading of this, and now you can find the gain of the amplification circuit in the first experiment. Another is load versus output of this total sensing circuit. That graph you can draw. So here one example we have given, that you can put the different load here, and you can measure the ADC input value, that is the output of this. So 2 MCU ADC, that values are there. So you can draw one graph, y is equal to mx line. So you can find some y is the our kg which we kept on this. So this is this axis, and these are the x values. So that x values if you put here, so this you can get as a slope, and this will be your offset value. You can get very linear response. With that arrangement, first experiment you can conclude. In the second experiment, there are 2 arrangement we gave. So with this also, if you are not getting any linear or any offset, if you are finding, so like that you can see here, we kept 1 kg. So this is the experiment 2, where we can see the calibration process. So second experiment is calibration. So after the setting this, finding this, that is implemented inside the code, still there will be need of calibration process. So now we kept 1 kg here. So here you can see 0.96 kg it is showing. So that is showing that there is some calibration error. So now this 2 key we gave here. So currently here value is less than what we kept on the load cell. So we will increase this by pressing up key. You can increase this by pressing the lower key, you can reduce the value. So here now we are calibrating it to 1. You can see now it is showing the 1 kg value, so which we kept. So now we can recheck by putting another load on this. So let us put 500 gram on this. So now you can see that by adding the 500, you can see here, so it is showing the same value. So now it our unit is calibrated. That is the second experiment. So with this 2 kit you can calibrate this. So now let us see third experiment. In the third experiment what we can do is, so let us remove this load and let's just keep 500 here. So now we kept 500 here. So here you can see the same value. Some calibration error is there that you can remove using this. So we have of given that values, so we are able to calibrate it. Okay, so it is the same value. Now you can see. So now load is there. So this is the enter key that you can press, that is the center key. So you can make, you can see that offset kg is set to 0.5 kg. So now you can see the reading is 0, though we have the 500 grams here, it shows 0. Now if we add 1 kg over it, let us add the 1 kg over it. So we kept 1 kg over it. So you can see now the reading, it will show 1 kg. Okay, so this is the 1 kg you can see here. So here we can see 1 kg with the offset. So now if we remove full, so you can see again it show the offset in the negative. So now there is no load and it is showing the offset minus 0.5 kg. So now to clear this, again you have to press 0. So now it is showing that offset is removed here, and now you can see it is 0. Now if we press 1 kg again, so now it will show 1 kg, you can see. So this is our load cell trainer.